Yeah, keep it in the first slide.
Please, sir, corner look at this.
Good afternoon, everyone. A warm welcome back to all the dignitaries, faculty members, participants, business scholars, and dear students. I hope you all had a refreshing lunch break. It is now time to begin the afternoon technical session, day 4 of our AACTE ATAL Faculty Development Program on Advanced EV Charging Technologies using power electronics from smart grid integrated distributed generation towards sustainable development goals. It is my privilege to introduce our esteemed resource person, Dr. Vasan Prabhu. Dr. Vasan Prabhu is a distinguished academician, researcher, and innovation leader with over 80 years of experience in electric vehicles, power electronics, battery management system, electric drives, and embedded systems. He holds a PhD in electrical engineering from Anna University, Chennai, and has served in prestigious positions including subject matter expert at Larsen Turbo Reputec, academic manager and tech lead at Great Learning, technical team lead at Skill Link, senior assistant professor at SRM Institute of Science and Technology, and associate professor at St. Joseph College of Engineering. His academic contributions including 20 research publications, 393 Google Scholar citations, and a H index of 11 and an I-10 index of 11. His expertise spans electric vehicles, battery management systems, manual signaling, electric drives, and sustainable energy systems. We are indeed honored to have such an accomplished expert with us today. May I now request our esteemed resource person, Dr. Vasan Prabhu, to kindly come forward and grace the dais. As a token of respect and appreciation, I request Sabina to kindly present a class sampling to our esteemed resource person.
Yeah.
Thank you, sir. The session is now yours. Over to you, sir.
Yeah, thank you. Okay, good afternoon. So listen, faculties, today we are going to discuss about the end-to-end solution of, am I audible right properly? Okay, fine. Understanding the end-to-end solution for electric mobility. What is mean by end-to-end? What are the things we are going to learn about electric mobility? So first I give the glimpse of it and then we jump into the session, right? So what is end-to-end? If you take any particular engineering system, it has the minimal component to system level thing. So around the particular system, we have the complete ecosystem for that particular product. Clear? EV is also one such kind of system. For the last 2 decades, it is quite popular in the market. So what are the things we have to know? So how it is migrated towards the next few years? What are the job opportunities are there in the electric vehicle? So once you understand the ecosystem, you can understand well about how the market is going to evolve. It is very interesting. Understanding the basic concepts, the design, these level of information is one aspects. The another aspect is understanding the ecosystem, how the future is going to evolve in that particular domain. So how you are going to fit yourself, or how you are going to train your students towards the ecosystem. So that is very interesting part. It is not a particular domain. Electric vehicle is a separate system which integrates electrical, mechanical, computer science, electronics. All the domain expertise are required to build the electric vehicle. So first we have to understand that part. It is a completely new theme. People are thinking electric vehicle, the buzzword electric, in the sense it may be a electrical engineering thing. It is a quite common thing. It is needed a mechanical engineer, electrical engineer, electronics, computer science, data analyst. So lot of engineers are required to build a complete vehicle. So in that way, I am going to give you the clear end-to-end information about the electric vehicle. What are the things we are going to learn in today's session? At the end of the session, what you can do, this is about me. If you want to connect with me, you can use the barcode. This is my LinkedIn profile. In every week or every 15 days, I have posted about the development about the electric vehicle, right? So my name is Vasan Prabhu Viramani. You can check that. By the end of the session, you will be able to, as a faculty members, you have to understand the whole system first. If you have a clear visibility about the electric vehicle, the entire system, so what are the components which is present, how the electric vehicle is functioning, and then you can start speaking about the terminologies in the entire ecosystem. You can start connecting these things as a interesting ideas to the students. Because EV is evolving, students are aligned their own projects towards the EV ecosystem, then the profile is completely fit for the market demand. So in the college itself, they have to learn these things, because whatever the academic syllabus, that things more information about the engineering, the basic conceptual thing, how the electric motor works, analog circuits, digital circuits, microprocessor, that is very, very essential. But that skill set has to be applied to any of the engineering product. So how to apply that part? So we are going to understand that perspective. So once you track the ecosystem, how the industry is traveling towards the newer market, how the India policies are promoting the particular segment, these kind of awareness is very important among the faculties. Then only we can teach the students how our ecosystem is going to transfer for the next 10 years. These kind of skill sets are very, very essential in the faculty circumstance. Then only we can teach these things to the students. The complete agenda, the terminology wise, it may be aligned with some specific domain. The mobility transformation. Mobility in the sense we are using our vehicles day to day, right? How the mobility is transformed from the ICE segment to EV segment. What are the reason behind the transformation? That's short basic introduction. And the EV system architecture. So what are the things which is combined in that particular architecture segment? So the overall view gives the end-to-end information about the architectural development. If you enter into the domain, we have to aware about the basic energy storage and the BMS system, power electronics and motors, charging infra, software part, and industrial process through the testing, manufacturing, and the outlook So I'm going to give you the industrial flow in the last point. So these are all the things we are going to learn. Clear? So first, my question is, why the mobility transformation is required? Why we are thinking about alternate transformation? The question is to you. Why we are looking for alternate mobility transformation? Running cost is low. But for the last 120 years, we are not much bother about it, right? The ICE engine vehicles are running in the roads for the last 120, 130 years. But why the last 10, 20 years? Are we thinking about only the running cost? Sorry, sir? Fuel price is day to day it increased, okay? Good. Another point, carbon footprint, it's keep on increasing. So one is cost aspects, another thing is carbon. Any other reason? So automatically carbon, which is aligned with the pollutional perspective. But any of you know electric vehicle is not a new engineering invention. Before IC engine, we have the electric vehicle in the market, you know. Why it is failed in those days? Why we are jumping into the ICE engine? Now why we resume back to EV? Travelers. Yeah, but it is not quite popular, right? People are not using EVs after the invention. But nowadays only people are thinking about the EV again. So it is a very old technology. It is not a new one, but again it is resumed back in different form. That is the only thing. Anybody know why it's failed in that? Because it may sustain some years in the sense maybe we can slowly evolve and improve the electric vehicle from those days onwards. It's completely failed. We closed the chapter, we opened the IC engine, and the past 120 years it slowly evolved. Currently we have the fantastic technology in IC engine. We have BS4, BS5, BS6. We upgraded and we are trying to reduce the fuel pollutions, right? Government introduced the schemes and now slowly we migrated to CNGs. They are trying to reduce the pollution. So over the years, the pollution level may be reduced gradually. But still, whatever you have mentioned, right? Fossil fuels availability is very limited. We could not able to get for longer run. We have to seriously think about alternate technology. That is one thing. Year by year, temperature is increasing a lot. In my childhood, I played in the entire day. Sunlight is not that much harmful compared to nowadays. The temperature level is drastically high, which is harmful to the people. UV radiation is increasing year by year, right? So these are all the basic reasons. Other than that, what else? If you dig deeper into the engineering, it needs lot of materials. The raw materials which need for build the electric vehicle, which is very huge. It consumes a lot of metals, water, production lineup needs, very complicated process, engine design. How many of you know in worldwide how many engine manufacturers are there? Who are all popular in the market? It's very limited, countable. In India, how many engine manufacturer, especially in automobile segment? Just think, not think about two-wheelers. In four-wheeler segment, how many own Indian make engines are there? How many companies? Can you tell one by one? Mahindra, Tata, Hyundai. Hyundai is not an Indian company. Maruti is relying on Suzuki. So Mahindra, Tata. Other than that, anybody here? Ashok Leyland. It's a heavy vehicle manufacturer. In a four-wheeler normal transportation, because our population is close to 150 crore, we are using millions of vehicles in the road, right? So these much huge people, huge number of vehicles. But if you think about our automotive companies, those who are manufacturing engines, only Tata and Mahindra. Tata initially starts tying up with several international vendors, Fiat, and they understand the technology. Slowly, they jump into the engine manufacturing. So, lot of troubles, poor failures in the engine design. Slowly, they evolve, and then they procure lot of foreign companies like Jaguar and all. They acquire. Now they have the comfortable design engineers. They build lot of new engines, new platforms. Like that, Mahindra is also tied up with a lot of companies. Slowly, they learn the engine design. Engine design engineering is not the easiest thing. It is a very complicated process. It has n number of components into it. So production line needs lot of process metals. Population is keep on increasing. So the amount which we invest in the car ride, that is keep on rising. So that is one factor. Like our mobile phone, if you build with a very low cost, if you can get more profit, so that is the alternate pathway, right? If you think about electric vehicle, it is having a very minimal number of components. It is not a huge, like a complex engineering, like a engine design, battery, motor, power converters. Can you tell now in the last 10 years, how many electric vehicle manufacturers you know? In the last 10 years, what are the companies they started in India itself? Can you tell? Ather. So what are the two-wheelers you know first? Tell. Hero. What is the brand of electric vehicle in Hero? Vida. Good. Hero Vida. Ather. TVS. iQube. Ampere. So like that we can tell more, right? In the last 10 years, it's keep on increasing. Around 150 plus startups, they are in the EV segment. For the 120 years of technology, only 2 companies evolved over the years. We have the technology in our hand. But EV is like a social media, YouTube. Anyone can make our own video and they can showcase your skill sets to the people, right? It is easily in your hand. Like that, electric vehicle is also not a very complex engineering. It is easy to understand. It is easy to build. We can build our own vehicle because batteries are available in the market. We can get from several battery vendors. Motor, it's in our day-to-day life. In a domestic appliances, industries, we are using motors. Only thing, we have to customize the motor as per the vehicle standards. Once you get a motor and a battery, electronics everywhere nowadays we are using ceiling fan, our inverter, ACs, refrigerators. If you open anything, the green color PCB board is there. It is the electronics and electronic circuits. So that engineering is already evolved a lot. We have the expertise in our country itself. It is easy to build this engineering. So one thing is it needs very lesser cost in the production line. So it is easy to produce and it is not a very complicated engineering. If you open the IC engine in the front portion, right, huge engine, lot of components, clutch, lever, gearbox, so many components. If you any particular component which may get damaged, every 6 months to 1 year, you have to bring your vehicle to the service station, you have to fill the oil, servicing the entire equipment in the frequent interval. But in the electric vehicle, if you think that ecosystem, it is almost 5 years. Are we doing service for our mobile phone in a frequent interval? Same battery pack. Instead of motor, we have the display. So it is discharging and we are using mobile phone, right? So like a mobile phone, our electric vehicle is also very minimal number of mechanical components. At the maximum, we have to go and check the braking mechanism, the lubrication in the brakes and brake pads. These kind of minor issues we have to address. Batteries and motors are rigorously tested. It is a fall-free motor. So the maintenance issues are completely resolved. So just in that perspective, if you understand about the electric vehicle, now you can understand how this particular engineering is going to penetrate our market very seriously in the future. How it is going to cut the ICE engine very soon, because production line cost is too high for ICE engine. This is very less expensive, maintenance free. So people can easily use that particular vehicle. No need to go for a petrol bunks to refuel it. In your home itself, you can do the charging. Once you install a solar panel in your rooftop, what about the cost of running? Only the depreciation of battery. Almost running cost is negligible. If you install the 3 kilowatt or 5 kilowatt panel in your rooftop, it is a future thing, because people are started erecting solar panels for rooftop, or smart grid systems are coming. So power is keep on power production cost. They may provide the very lesser price in the power. If you have the surplus power in the grid, they may provide with a lesser price, right? So running cost is like a mobile phone call cost. It is keep on decreasing in the electric vehicle segment. These particular people could not able to know 20 years before. If you check the mobile phone call cost, it is too high. Now, yeah, we have to pay for the incoming call also. So how drastically it is coming down? It is a technology. Once it's evolved, automatically technology bring the cost to the lowest point. Like electric vehicle is also nowadays like a mobile phone. After post lunch, it is hard to listen. That is the reason I'm not taking a class in a deeper technical aspects. Just you are going to understand the complete ecosystem perspective, right? So that is the reason I'm talking to you in the general aspects. So once you understand the end-to-end ecosystem, why it is penetrating the market, slowly I can penetrate a bit deeper into it. Because normally I can talk motor design or battery design. It is too hard to listen in the second session, but I'm just starting with the flavor of common thing. Slowly we can feed the concepts, right? If you have any questions, feel free to interact. This is not a lecturing session. I'm not going to teach anything deeper technical part. I'm going to give the idea how to understand the market scenario, how to align yourself with the market trend. So these are all the things we are going to discuss. So try to interact and ask questions. In that way, it is more effective, because it's a post-lunch session. So start asking questions, we will interact. Clear? So till now, any questions? Any basic ideology, because we discuss about the evolution of EV, right? How it is evolved and all. Do you have any questions? Okay, let's jump into the part. Now, the mobility transformation, I will show you. Sorry. IC versus EV, that is what we have discussed. Once you see the electric vehicle sales in a different segments, we have two-wheeler, three-wheeler, passenger vehicle, three-wheeler, load vehicles. So every segment, how the vehicle sales is increasing over the month. If you can check the statistics, you can understand how the IC engine vehicles is depleting and how the EV vehicles are penetrating the market. If you can look our India, so lot of production line is keep on increasing in the EV segment. In our country, especially two-wheeler and three-wheeler is selling very faster manner. In Chennai, I can see lot of three-wheelers now with the green boards, because for the local commutation, two-wheelers are best, because with the shortest distance, it is more preferable. For four-wheelers, slowly the charging station are popping up at particular interval. So cars are also very soon migrated. You can travel 300 to 400 kilometers easily with the four-wheeler also. So this is the scenario. You have to understand what is the scenario up to July, how the sales count is there in India. So these are all the points we discussed. So what are the energy sources we used in IC engine as well as electric vehicle? Powertrain structure. How many number of moving parts in IC engine? It is 2000 plus moving parts. See, that is 20. The moving parts are limited in the electric vehicle. Two zeros are coming down, right? It is 100x times. In any engineering system, 10x, 20x times if you reduce, that is biggest achievement. Here, 100x times, 20 to 2000. They are reducing the number of components 100x times. It is a huge achievement for the transportation segment. Efficiency level, if you check, if you fill the fuel, the mechanical engineer may know about the efficiency of the system is very low. We are getting a better mileage. You may think for per liter I may get 20 liter, 22 liter, but actually if the system efficiency is 85, 90, in the sense per liter we can get around 80 kilometer, but our vehicle efficiency is very poor. This is peak. I have marked in the peaker level, but normally tank to wheel efficiency, if you fill the fuel tank, whatever the range you are getting, it is only 11-12% of the actual performance. In EV, it is producing 90% of the efficiency. Whatever the power we are generated, which is charged into the battery pack and we are utilizing for transportation purpose, inside the vehicle if you check, the efficiency is close to 90%, above 90%, but if you are including a transmission losses and all, it is drastically coming down. That's why we are preferring rooftop charging or microgrid based charging. Localized power production may improve the efficiency a lot. So there is no carbon emission. That is the added advantage of the electric vehicle. See, we can.
Cars for internal combustion engine cars, which is better. Electric cars were invented back in 1900. But a sudden rise in petrol engine cars, accompanied by battery technology, has killed electric cars by 1920. However, with recent improvements in battery technology and power electronics, electric cars have given a strong comeback. We will compare these totally different technologies scientifically and how to understand which is superior. An IC engine is a prime mover in petrol cars. The fuel supply to the engine produces combustion and enough pressure and temperature energy to move the pistons. The linear motion of the piston is transferred through rotary motion using a slider crank mechanism. A transmission is used to transfer this rotation to the drive wheels. In an electric car, the power source is from a battery pack. An inverter converts the DC battery power into three-phase AC. The three-phase AC can turn an induction motor, which will thus turn the drive wheel. Now, let us directly compare these technologies. In an IC engine, the force and power production is never uniform. The reciprocating components cause substantial mechanical balancing issues. In addition, the engine is not self-starting. Many accessories are needed to sort out these issues, which makes an IC engine quite heavy. Such issues are not there in an electric motor.
What are the points they have mentioned? Over the 120 years, what are the evolution happen in the IC engine? IC engine, they introduced the counterweight is there. It is not self-starting. Previously, hand cracking, they have started with the hand cracking. You can see some autos, in the olden day autos, they may crank it, right? So that kind of technology, they started with the IC engines. But later on, they connected with the small starter motor, which ignite the engine. So the linear motion is converted into circular motion. So that is the reason IC engine is very complex. It is not a direct rotational energy. We are converting a linear motion into rotational motion. So that is what we build with the IC engine, right? But in that also we are using a motor assistance to initiate the starting process. So motors only promoting the IC engine in those days also. But we are using DC motor and small battery. But we are not using for propulsion purpose. We are using same battery and small DC motor for initiating the engine process. So again, battery and motor, it is miniature version which is going to crank the engine, and we are getting the rotations. So same battery and motor dominates the market in the form of IC engine. Without battery and motor, if you are thinking about IC engine, it is nowhere popular, because with the assistance of motor only, now also our IC engine is more comfortable. Steering wheel, which is also having the small motor into it, provide the comfortness in the steering wheel. Otherwise, if you drive the lorry and all nowadays also, it is so hard to drive. In car also, you can spend your huge efforts in the steering process. So like that, motors always assisting us. Motors are the best component to help the human being for all our domestic appliances, industrial process, and everywhere. Now we bring the motors to the transportation purpose for the direct propulsion. No one is competing with motors. That is the beautiful information about motors. Motors are dominating all the segments, because through the electromagnetics we are getting a rotational motion. So that is the actual requirement. We have to travel the wheel in a rotary motion. IC engines are producing the linear motion, and then we are converting with the mechanical arrangements for rotary thing. But electric motor, which directly produce the rotational motion, so no need of heavy mechanical components to transform the motion direction from linear to circular. So that is the reason the number of components are drastically down. This is the basic conceptual aspects. Clear? So that is the thing here they are comparing. Initially they started using with induction motors only. So I think you people know about what kind of motors we are using in electric vehicle. Anyone know what kind of motors we are using currently? Brushless DC motor, and then PMSM. Quite good. So what is PMSM? Super. Why we pick those motors? Why not induction motor? Because that is what the evolution. In the invention period itself, they have started using the best options, right? Why they go with PMSM and BLDC motors? Because we have to know switching is very fast. Okay. Any other reasons? Ma'am, your side? Why we are you in a sleeping mode? No, right? Why we are picking PMSM? Feel free to connect. I'm not going to scold you. Just tell me why we are going with PMSM. The answer is several reasons are there. First we start with, nowadays any electric motor which is going to integrate with the powertronic circuits. Through the powertronics only we are going to power up the motor. The biggest question is, we are using a DC battery. It is in DC form. Why not we opt for the DC motor? Because no need of conversion and all. We can directly power it up, and we can use the battery source in a DC itself. But the problem is, the DC motors have a lot of problem. We know carbon issues, commutation problem, armature reaction. We know that. So it is absolute. We remove that particular motor. Next widely used motor is induction motor, but in automotives we have the one requirement. We need a compact motor which has to be powerful. If the motor is too heavy, which is adding the vehicle weight, the power which is consumed from the battery is very limited. So if the motor is not efficient, we are not able to travel for longer distance. Each 1% efficiency may change the range level. So we need a longer range. Why the induction motors are used so many years for our domestic and industrial segment, why they are not looking for alternate motors? Why in automotives only we are looking for special category motors? The reason is we are running those motors from the grid. There is no scarcity in power limitations. We are getting continuously 24/7. We are getting the power from the grid. So induction motor efficiency is around 85%. So that is more than enough. 15% losses are acceptable. But if you are entering into the EV, batteries are having the limited source. If you are keeping a huge motor with 85% efficiency, what about the range? The alternate option, some other motor may have much lesser weight, torque to weight ratio, which is lightweight but powerful, which is having the high power density and energy density level, then still which is providing 95% efficiency, 10% extra efficiency, then engine is automatically jumping from induction motor to BLDC and PMSM motor. So these are all the reasons they are migrated from induction motor to PMSM and BLDC. Tesla, they invent the electric vehicle in the year of 2000. Who know the year? If you are seriously following the electric vehicle market, right, you have to know these things. In 2009 to 10, they launched the first vehicle. What is the model name? Roadster. If you see the Tesla vehicle, which is launched in 2009 to 10 in the name of Roadster, which uses the induction motor as the primary propulsion source. Over the years, they found the alternate motors. Now Tesla migrated to PMSM, permanent magnet synchronous motor, because Chinese, they started using the BLDC and PMSM for their own vehicle market. So they got to know this motor had better efficiency, energy density. They are using a high grade magnets, high quality magnets. We have different grades in the magnet. Rare magnets, N45, 52, we have different grades of magnet in the market. If you use the high quality magnets in the motor, efficiencies keep on increasing. So without additional power source, we can utilize the stored energy in the magnet. So that is the reason motors which are widely, PMSM and BLDC is widely used for the last 15 years. Now, people are struggling to get the magnets. China restrict the raw material supply to other countries because they want autonomy. They want a complete control in the market. How the Arab countries dominating the market with the crude oils. They have the resources, natural resources, right? With that, they are dominating the world. That is the reason those countries are very wealthy without doing any much hard work. They dig the ground and they taken out the crude oil. They supply the barrels. They get the dollars. They are building the huge infrastructure. They have the complete wealth. So with that crude oil supply, America is also getting richer through the dollar conversion. So they are, so like that, countries are very conscious about how to get a money, how to do the business without doing much hard work. So in that aspects, previously Arab countries has the resources, US utilize the particular resources, they are building their own wealth. China know that, and China understand the market scenario. This is the futuristic track. So magnets are the ultimate source. All the automotive companies relying on magnets. So they keep on raising the price of the permanent magnet. So they restrict the supply and increase the demand. Now the magnet, through the magnet supply itself, they are making huge money. So the BLDC and PMSM motors nowadays, not only in EV, they started using air conditioner also in the name of inverter AC. How many of you know what is inverter AC? Because in electric vehicle, what you see, the same motors only, here they are using permanent magnet, either BLDC or PMSM, they may use in the air conditioner also. So how it is effective? Because around our domestic appliances itself, we are changing the motors, the technology changing day by day. So we have to observe that whatever the courses we learn, parallelly we have to observe the market scenario, worldwide scenario, how the technology is changing every day. If you have the knowledge, that is very important in the corporate segment, because once who know the fundamentals, that is not completely sufficient. That person has to do the R&D work. They have to know market scenario, research trend, and raw material availability. These kind of information no one can come and teach you. Nowadays AI tool is there. If you want to learn anything, it is available through the resources. You can learn. But if you are not ready to learn, that level of knowledge itself, it's indicating 4 years how you spend your time only with the textbooks and examination. That is completely outdated. Nowadays all the companies are expecting skill. So how much skill you are acquire from it? So that kind of approach is the current trend in the market. So you have to observe that all the industrial transformation, how the industries are evolved over the years, why the changing happened from ICE engine to the electric vehicle industry, how the motors are evolving, how the batteries are evolving, how the charging infrastructures are evolving. If you observe the entire ecosystem around the electric vehicle, you can fit yourself in any segment. You may learn that particular part, right? That kind of possibilities are there once you understand the ecosystem. That is the reason I picked the end-to-end point. The entire ecosystem information is very essential. Clear? Any questions? Yeah, why the world is moving to electric mobility. We discussed the climate commitments, energy security, falling battery costs. Because if you check lithium-ion cost, over the years, the per kilowatt costing of the lithium-ion battery is drastically down. So now the battery technology is coming cheaper. So that is one reason. The cost of ownership. EVs are going to coming down. Future automotives pricing are very cheaper. It may be your iPhone price, you can get the electric vehicle. In cars also, at least 2 iPhone price, you can get 1 electric car. That is the way the cost is coming down. Air quality in the cities, which is the serious concern. Especially in India, we have 6 metro cities which is having a poor quality index in the air, especially our headquarters. These are all the main reasons. Clear? I think, yeah, for me. Okay, fine. Yeah, sure. Okay, let's see. So this is the graph from 2018 to 2025. If you check, in 18 to 20, it is progressively very slow. After 2020, see the pricing, see the sales count. The global EV sales starts from 2020 to 2025. It's keep on increasing. After 25 to 30, if you check, the graph is almost non-linear. It is vertically going to increase. Because any technology evolution, if you check the graphical pattern, slowly it starts. Initial phase may be slow. After that, at some point of time, the graph is drastically picking up. So now we are in the transition era. It's a constant phase. After 2020 to 25, gradual increase. Now in 26 to 30, you are going to see the huge revolution in the market penetration. 26, it's the initial phase. Next 4 years, you are going to see the major revolution in the EV industry. 2030, our India target is 30% of the automotives has to be in EV form. It is two-wheeler, three-wheeler, four-wheeler, heavy vehicles, buses, inclusive of all the segments. India targeted 30% of the vehicle has to be EV. But beyond that, we are going to reach, because the other countries, especially China, already 60% of the vehicles are in the EV segment. They migrated in a very fast manner, and they are targeting 10% very soon. And other countries are also have the huge target. So that is the reason I mentioned the next years is the rapid growth, right? Once the rapid growth is happened around the vehicle market expanding very rigorously. So you can see the job market, it is booming up very broadly. You can see that is the reason I observe the statistics, how the engineering admission is going to happen. The next 4 years, EV ecosystem is booming up. Renewable energy is booming up because we need huge power. Why the huge power demand is there? Not because of people, not because of other things. We are going to boom the EV. We need charging. So charging power demand is going to hike. Once the charging demand is increases, we have only two options. One is renewable, another one is nuclear. So that two options are only we have. So we are going to booming up in the power sector, EV sector, and we are installing the data centers also. Coming to that particular technology, data center is also needing a huge amount of power to running the servers. So power sector is the next huge demanding sector like IT. We are going to see those changes in the next 5 years. Additionally, our government policies are promoting these technologies because we are highly polluted country, highly populated country. We need this kind of technology for saving our economy. Currently, our most budget amount is going to purchase the crude oils for the dollar conversion and the crude oil purchase. If you save that amount, India soon become a superpower, because if you save those money, we can build our infrastructure very quickly. We can build our huge data centers internally. So that is the reason, compared to other countries, the highly populated India need this particular technology to save our money, save our country, to avoid the pollution aspects, right? Because of huge population per square feet in that particular city, right, per square kilometer, how many people can accommodate? If you take the survey all over the world, America, England, if you check all those regions, right, per square kilometer, the people density is very less worldwide. Especially if you check China, China is also bigger region. It is a location wise, we have the large landscape, but in India we have the limited landscape, highly dense people. If you are consuming the power and using the vehicle, pollution level is drastically high. That is the reason our metro cities are highly polluted. So we need this transformation. Delhi recently absolute the ICE engines. They release the policy. The next few years, they are not allowing to run the ICE engines inside the Delhi. Only electric vehicles are allowed. This is not only for the Delhi. It is going to come to our cities also very soon. Government is the major driving force to kick the electric vehicle penetration. They start with the FAME scheme. How many of you know the FAME scheme? FAME 1 and 2. What is that? How many of you know FAME? Nobody. This terminology is completely new to you. If you purchase electric vehicle, government provide a subsidy. Some amount is given to the government side. They may provide the money to the people. If you are going to purchase the vehicle, government share the amount. That is FAME scheme. FAME in the sense faster adoption. ME. What is that? Go and check, Google it. Why the faster adoption schemes are implemented for EV, how they provide the incentives for it per kilowatt, how much incentives government provide. So that is the first initiative government did to promote the electric vehicle in the initial graphic line, because the graph is not started, right? Government provide the incentives, people go and purchase, I give the money. So they provide the money to purchase the EV. Once it's the kickoff started, they slowly reduce the incentives. Now they are almost stop that particular thing. So this is the way government start initiating these kind of policies. Now they are providing the subsidies for solar installation. There is a scheme, you are going to install your solar panels in your home, government provide the subsidies. Now they started promoting these things in the sense they want to initiate the process, because government could not install the solar panels in the landscape to produce the power, because India is having the limited landscape, our population is high. So what we can do, we can install the panel in our home, we can utilize the power for ourselves from our own production line, then the power demand is drastically low, right? So this is the best possible solution like our countries. That is the reason government started promoting solar panels, but which is not quickly adopted. The reason is most of our consumers are less than 100 units they may use for the 1 month. Solar production may produce, right? That is the reason they introduce grid connection. We can bidirectionally transfer the power. They introduce lot of schemes. So these kind of information, it is mandatory. Once you start using the EV, automatically unit consumptions are keep on increasing. You are not going to fuel your vehicle. You are going to consume the units from your own power production. This is going to happen. You are going to see in the next 4 years, how many of you going to install the solar panel in your home? How many of you going to use the electric vehicle? You see 2030, technology adoption is in very high rate. Just keep that in mind. You can recollect 2026, some faculty mentioned about these things. Now I'm installing solar panel, I'm started using EV without spending money, I'm using the transportation. So this is going to happen very soon. This is the market scenario. I have mentioned about market scenarios, right? See, electric two-wheeler sales. I bring the data from the Vahan dashboard. Real information, which is from August 2. Statistics. If you take, I picked from the EV Reporter magazine. The sales wise, what are the companies are dominating in India? See, Honda motorcycle, which is the #1 player, they sold 4,69,000 vehicles. In that, they sold 4,68,000 vehicles in the IC segment, and only 937 EVs. The EV contribution is only 1-2. What is the model they have? You know, Honda. Anyone know what model they have? What is the popular model of Honda? It is not a four-wheeler. It's a two-wheeler. Honda, which IC engine is widely popular? No idea. Activa, man. Activa is the most successful model of Honda. Other than that, they may sold the bikes Unicorn and Shine. So if you check the statistics, Activa is widely sold all over India. So the penetration is very low because recently they migrated to the IC market. They are not yet evolved fully, but once the complete EV model launched everywhere, they may be increase the count. Recently they launched the Activa version in a EV. If you check Hero motor car, they sold 4,40,537. We know which is the popular two-wheeler in the Hero. Splendor, good. That is the one. Still, the count is too high because compared to other models, Splendor is one of the more successful version of Hero, but IC engine is 4,17,000, 22,887, now 883, 5.2 percentage. Now, if you compare IC engine versus EV penetration may be quite low, but now it is in the numerical level. If you check the 2020 data, everything is in single digit, everything is in fractional, but now 5.2 percentage, which is one of the India's leading market player. TVS, if you check, TVS launched the iQube much earlier than the other companies. Vida, because Vida itself, they may sold around 22,000 in India. If you check iQube, 55,465. Worldwide, if you check small countries, which is a very big number for them, per particular month, the statistics and the particular time period, right, the 26 to the last previous, after April, the sales count starts. 55,000 is the big number, which is 14.8 percentage. Bajaj, which is equally competing market, which is having 1,80,000 in that, see, compared to EV in the iQube, which is having 45,562, which is the popular model. Chetak is the popular model of Bajaj, which is 45,562. Suzuki, if you check, only 0.04, EV is not that much popular. RE, which is not selling, they are having the prototype, very small compact vehicle. They are testing that particular model. If you check, they are building the EV vehicles also. But sales wise, mostly they are in this particular segment. India Yamaha Motors are also tied up with 167. I think River kind of company which is connected with Yamaha. They are in the production line. They produce the EV vehicle for Yamaha. Other than that, the green indications clearly mark the EV vehicles alone. Ather sold 30,317. They are not in the IC segments. 100%. 30,000 vehicle. Ola Electric 14. Ampere vehicles 10,127. So the last three companies which is selling the pure EV vehicle, why these pure EV companies are not penetrating like a regular automotives? They are the legend. They have the huge network, service sector, Hero, TVS, Bajaj. They are the big players in the market. So it is very hard to compete with them. But Ather is the fantastic vehicle compared to all other automobile. Ather engineering is fantastic, but still people could not understand the inner engineering, right? They are aesthetically, they believe the brands, Hero, Bajaj. So that is the reason. Still Ather struggle, but very soon they captured the market. Once you started using the Ather, you can feel how comfortable it is to ride the two-wheeler. And then, and I'm not going to read all these things, just having 98%. Tiago vehicles 21%, TVS Motor 64, Atul Auto 16. These are all the pure auto manufacturer, Mini Metro, Delhi Electro Auto, Omega Siki. Almost they are selling close to 1,000. And this is goods vehicle, L5 vehicle. If you check, this is the count for the EV vehicle sale. So market wise, in all the segments, now the EV penetrates. Here, this is our four-wheeler market. The leading player in the India is Maruti Suzuki. They started selling the electric. In the sense, it's a hybrid version. How many of you know Maruti launched the hybrid version of the vehicle? Pure EV is also there in one model. Which model it is? Which Maruti model? Check in Google and tell me at the end of the session, okay? Check. Which Maruti model launched with the electric version? Lot of hybrid models are there. After tied up with Toyota, they got the hybrid technology. That is the reason Maruti tied up with Toyota. They share their platforms. You know, Baleno, Maruti Baleno, which is in another name in Toyota. What is the name of the Toyota car? You are not much aware about the automotives. Clients, you know, like that, they share their own platforms. Ertiga is launched in another name in Toyota. So you people know, right? Why that Maruti share the technology or platforms to the Toyota? Because they want the hybrid technology. Toyota is the leading market player in the hybrid technology. What is hybrid? Fuel and EV. Combining both fuel and electrical model. So combination of both is the hybrid version. So Toyota promotes the hybrid version. So one aspect is pure electric, another aspect is hybrid. Why the hybrid is quite popular in the market, especially in the selective regions? Because people are having range anxiety. Those who are using electric vehicle, if you see, they are keep on maintain their eye on the display panel, dashboard. Why? They are keep on checking their range. If anywhere the vehicle struck, they have to walk and move the vehicle. But if it is a two-wheeler, they can travel with that. But if it is a four-wheeler, we can't do anything, right? That is the reason still people are not 100% believing the electric vehicle. Those who have the discipline, properly do the charging and maintain the vehicle, they are not bothered about that. But indiscipline, they are forget to charge the mobile phone. Always they keep with 5% of 10% of charge in the mobile. Always keep the power bank with them. That kind of people, they struggle with the electric vehicle because we could not carry the power bank for electric vehicle, right? So that is the reason they go with hybrid. So once we have the two options, we can fill the fuel or we can do the charging. We can use both. So immediately it can hit the particular market, right? So just for fun, I tell, hybrid is the fantastic technology in the current transition because anything from pure IC to the next corner is EV. In between, the sandwiched version is the some part of engine has to be with the reduced size and some part of EV. If you combine both the things, we can get a fantastic technology. We can get a better range. For the 1 liter of petrol, we can get 30 kilometer range. That is the highest possibility. Some companies, they try to push the range beyond 40 and all. Through the series hybrid, they try to bring more mileage in the vehicle. So people are working on that for avoiding the charging and to extend the range. So they try to build the technology. Toyota is the market player. So Maruti believing on IC engine platforms. Toyota is popular for IC engine platform. They could not simply left the IC engine because they have the beautiful technology in their hand. They have the CVT gear systems. So electric vehicle replace all these things. No need of all the concepts. No need of gears, CVTs. If you check Hyundai, they introduce different gear system, automatic, CVTs. So like that, a lot of gear itself, a lot of technologies are there in their own hand. If you purchase the Toyota vehicle for the next 3 lakh kilometers, no issues. That kind of durability they may have in their own technology, but sudden transition make the complete revolution change. So that is the reason Toyota promote hybrid technology. Maruti align with that. So they want to survive. So automatically they combine together. They share the knowledge to compete with the market. to slow down the EV penetration, they bring new versions of hybrid, they launch and populate to the people. Now people are started purchasing hybrid. Next 5 years they may use their own vehicle. So they slow down the market and then they can adapt to the newer platform. They can bring the electric vehicle slowly. So that is the reason this kind of collaborations may happen. They understand the market scenario, immediately they collaborate. Previous to the EV lineup, it is very hard to collaborate. Suzuki is a separate giant, Toyota is a separate giant. They are not collaborating each other. But now EV make the compulsion and they do collaboration. They bring newer vehicles to the market, interesting vehicle. So this is called observation. Once you start observing the market, you can easily grab the concepts. This is in a day-to-day life, it will happen, right? New vehicle launched in the market. What kind of platform they may release? Is that the hybrid platform? Is it the EV platform? How they bring the particular thing? So if you start observing the new versions and its own specifications, so slowly you can get the concepts behind it. This is the way you can easily align with the technological evolution. See, this is graphical information, I mentioned about the FAME scheme and all, right? The FAME 1 and 2. So these are all the India policies. FAME 1 and 2, that production linked incentive for advanced chemistry cell manufacturing. If you are going to start a new company in the electric vehicle, so they provide lot of loans through MSME. So startup schemes are there. So in that particular segment, you can get lot of incentives. That is the reason so many startups in the EV lineup. I said, right, 150 EV manufacturer startups are coming in the market. All are getting incentives through the particular scheme. We are not aware about it, but once you start visiting the MSME websites, what are the government incentives they may provide for the startup, right? You can write a proposal, minimal fund. You can get it from the bank. You apply to the government portal. So partial amount from the bank, partial amount from the government subsidy. You can start your own venture. Only thing is you need an engineering concept. You have to understand the market scenario. You have to launch your product. You have to build your own business. The thing is, no need of getting a job in a company. That is no longer work it out, because lot of automation is going to happen. So industries are make a profit through the automation process. But for the next, whatever the EV technology I have mentioned, right? Like that, the future scenario is group of people, they may start their own company. They can share the revenue in the market. EV is the huger pool of water. You can take your water from the ecosystem. You can start your own company. You can get the share from the complete ocean. So this is the way you can make the revenue. The thing is, you have to be very smart. You have to be technologically well. So then it is easy to fit into the market. That is the futuristic scenario. If you see the IITians previously, all are migrated towards US to get the job in the abroad in the IT industry. That is one trend. Nowadays, IITians also started their own ventures in the IIT campus itself. They incubate in the campus itself. They build their own business in the engineering period itself. After the final year, they start their own company outside. So this is the way now the trend move towards the startups. Within a short span of time, they make millions or $100 company, $100 million companies are there through the AI. If you check ChatGPT, once they penetrate in the market, later that Claude, right? Once the Claude launched, within a short span of time, Claude starts competing with OpenAI. Lot of AI companies are there. The top two between OpenAI and Claude. Still Google, Gemini AI and all struggle to compete with Claude, Anthropic in the OpenAI companies. So like that, the trend is no longer the sustainable companies always win. If you have the good technology, if you have the new product, you can penetrate and hit very quicker, the market will open very soon for your new innovative products. That kind of dynamic market is. So only thing is you need a smartness. Clear? So if you have that kind of thing, you are easily get the awareness about the government policies, and then you can start your own business with this incentives. And who makes up the ecosystem? OEMs. We know vehicle manufacturer is contributing a lot. Tier 1, Tier 2 supplier. You may start your business not only manufacturing a EV vehicle. You can supply any of the components, and cell and battery makers, charge point operators, companies deploying and operating public charging networks, and government policies, regulatory things. You become a ISO auditor. So electric vehicle companies need a lot of ISO auditors, those who know about the battery technology, so they can play their own things in the vehicle audition, inspection. So that kind of auditors roles are coming. Academia and skilling bodies, that is the another important segment. If the new technology is going to penetrate, they need a skilled workers. So for training those peoples, academia is not ready up to the technology evolution. Now the evolution is rapidly changing. Every 6 months new technology is coming. Previously they are talking about open AI, artificial intelligence, now agentic AI. Now because that is changing dramatically, within 3 months, 4 months, new technologies are coming. If you start learning about how to build the open AI or build the artificial intelligence toolbox, now they bring the agentic AI. So the technologies keep on changing. It needs rapid changeover in the education system. So that advancement is required. So learning the fundamentals and learning the other things, that the recent advancement also, it's a part of the ecosystem to bring the skilled working professionals to the new industry, because it's a fresh industry. It needs fresh people, so they need a different kind of skill sets. The older engineering, the older systems drastically changing to the new era, it needs new skilled peoples, right? They need some sort of engineering fundamentals with AI skills. They have to work in a new domain. So these peoples need, with engineering and artificial intelligence skill sets, they have to work in a different vertical. So that skilling is also one of the important part in the ecosystem. These are all the types of vehicles we have discussed. About the Toyota I have mentioned, right? These two technologies are in the hybrid technology. This is battery technology. The another one is fuel cell technology. It is also part of the electric vehicle segment. Why the fuel cell is coming in the picture? Where we are going to promote the fuel cells? If you are going to run the heavy vehicles, trucks and all, right? Truck has to start from our southern region, like Tamil Nadu, Chennai point to Delhi. It has to travel a very long run. If you are going to run that particular truck with the electric vehicle, frequent stopping is required to do the charging. For charging, almost it may take 7 hours to 8 hours. So if you want to travel from the southern part to north corner, it may take very longer run, right? So that kind of vehicles with a heavy load, the normal battery is not sufficient. So that kind of vehicles may prefer fuel cells. We have the place to position the fuel, and we can generate the power dynamically. We can run the vehicle. So that is the reason we have different segments. Each vehicle, either for two-wheeler, pure battery is fine. For the car, hybrid is fine. For the heavy vehicles, fuel cell is fine. Like that, the future market is not aligned with only one technology. It may be diversified. Then IC engine is also part of the engineering. It may be in the car market. So hybrid cars are sustaining for few years. And the fuel cell market is for buses and trucks. For heavy vehicles, they may go with fuel technology. For pure two-wheelers, they may go with battery electric vehicle. Two-wheeler through three-wheelers, local commutation, they may go with pure electric. So this is the way all the segments are going to capture the different market. So people are going to use different technology. Once if we reach the battery technology to the next level, for longer range, if you are getting from the small battery chemistry, pure electric is everywhere, but up to that particular time period, so the total market is split into multiple segments. Almost we spend 1 hour 15 minutes, but single question is not popping up. So now 1 minute break. Just whatever the questions you want, just try to ask. Otherwise, again, it's a lecturing, right? We are not discussing any deeper engineering. We are discussing the industrial scenario, how the market is evolving, how industries are aligning themselves towards the EV. So if you get really connected with the EV segment, then we jump into the real core components concepts, batteries, motors. I'm not jumping into that part till now. Overall, now you understand the overall scenario, right? How the engineering is evolved towards the EV. Is that clear? Any questions? Absolutely good question, ma'am. Actually, cost of the hybrid vehicle is too expensive compared to electric vehicle because it needs engine, gears, electric motor, batteries, everything is accommodated, right? But costing is too high. But still, we don't have the charging infrastructure. You have the range anxiety. You need a electric flavor as well as the conventional driving experience. You are affordable. You may go with hybrid. That is the only thing. But they may reduce the pricing. Within 20 lakhs, you may get a good hybrid vehicle. But electric vehicle nowadays, Tata release Tata Tiago, pricing starts from 7 lakhs. That is the range. Difference is that. But you can get different kind of fuel. If you start using a hybrid vehicle, it is too heavy and a lot of engineering is there in it. Energy management system. You can fuel as well as charge now. You can get a longer range. No need of frequent charging. If you are with a Tata Tiago, after 200 kilometers, you have to wait for 3.5 hours to do the charging. But hybrid vehicle, no need to stop. You go to the next petrol station, fill the fuel, automatically the vehicle itself charging the battery and extend the range. So per liter, it may provide 30-35 kilometers. Normal vehicle may provide 10 kilometers, 15 kilometers, right? So it may provide longer range. So currently it is viable. So people are going with XUV, right? In India, again, the story is going back. In the olden days, in the automobiles are new to the India, popular model is almost Maruti 800, Maruti Alto. So much of people started purchasing those vehicles. People are looking for normal sedan. That is the next step. In that particular time, the Honda City is entering into the market. Honda City is very popular. The luxurious people, they may afford the Honda City. That is the top end car in those days. So almost all the people are having Alto. Alto is the more successful model of Maruti in those days. Now people buying capacity is increasing. Now the minimum successful model of Maruti is Swift Desire. Alto is not that much popular nowadays. The sales count is drastically down. What is the more successful model in India now in automotives? XUV cars. People are more concerned with the XUV models, not sedan or hatchback. Now India buying capacity is jumping from hatchback sedan to XUVs. So that is the reason all the automotive companies are changing the shape. It is not the real XUVs. People know about engineering, they can understand, is that XUV car? Real XUV car is a Mahindra, they launch XUV 700, 500, right? So the powerful engine, which may have all-wheel drive, The powerful engines are XUVs. Now, lot of companies changing the shape of the vehicle. Hyundai changed the i10, i20 vehicle platform. The body shape is changed like a XUV. They launched to the market. Now people are started buying the shape. Only they need height and broader body. So they are going to purchase the vehicle, which is not that much powerful. The engine is lighter. The body is look like a bigger one, which is mostly customized for India. If you look Renault have Tribor and one more vehicle, Nissan, I think. Nissan is tied up with Renault. They launch the same platform for both the vehicle. They launch 5-seater and 7-seater car, look like a XUV. They launch with a 1000cc engine. But people are not bothered about engine capacity because deep engineering they don't want. They are seeing the look, they are purchasing the vehicle. So the budgeting is, India's budget is now 10 lakhs to 20 lakhs. Creta is very popular, and the French company Renault is started that XUV trend with the name of what is the brand, the car name? First XUV in India, Renault Duster. Duster is the first XUV model which is more successful in India. After that only all the automotives are migrated towards that version. Before that, people are building hatchback and sedan cars. But Renault first launched the XUV version, which is very much successful. Before that, some other models in the market, but still that is not popular in India. After the Duster craze only, all the automotives are jumping towards XUV. Now Creta, Kia, which is the most selling cars in India. Again, the same Renault launching the Duster, but it is not hitting that much. Because I am automobile, more craze about EV, right? I am closely observing all the automotives. What are the engine platforms? How they build? How many motors? What is the spec? If you are seriously looking those development, you can learn the technology. So if you just expand from that, I am learning from the market expansion, how the automotive companies are working for the particular platform. What kind of platform Tesla made? What kind of platform Tata made? What is the difference between the international branding to the local branding? So how the chassis, batteries, cell chemistry, motor type, BMS, dashboard, telematics, IoT, cloud connectivity. If you look into the vehicle from the international brand to the local brand, you are getting a lot of insights. Only thing is you have the keen interest on the particular segment. Once you have the interest, no one can stop. You can learn from the AI and the online platform itself. Just visit all the companies, just read all the documents, whatever they have shared about the technical specs. So you can start learning engineering. So this is the way I started learning, and I did my PhD research, everything in that particular segment. So for the long term, if you are doing the same task continuously, the continuous learning, you can get the better skill sets in the particular domain. Clear? This is the way I learned the EV. So this is the huge scope, right? So staffs and faculties, you can learn in the similar way. You can build your skill sets. I have the skill set in the EV segment. I know how to build the EV car in a MATLAB environment. So knowing one software is essential. Once you know the concepts, I want to validate it. Just use the toolbox and build the model in the simulation platform. Play with it. So this is the easiest and interesting way to learn new things. Clear? Now coming to the end-to-end part, the next segment we are going to discuss about the deeper part, batteries, motors, how the engineering is inside the components. So in that we start with the cell chemistry materials, how they build the batteries and BMS, motors and powertronics, and how we are going to control all these things with the vehicle software, how we are going to incorporate safety, and how we are going to do the charging with the connectivity of grid. This is somewhat deeper into the vehicle segment. Clear? Sir, what is the break time actually? Yeah, we have time. So now, before going to the deeper part, just to have a glance, revisit the entire thing, and then we go for the deeper part. So EV is not just a motor and a battery. It's a system of systems that must work together reliably, safely, and efficiently. So people may think electric vehicle. So plenty of courses in the market. If you visit those courses, they may talk about motors, they may talk about batteries and power electronics. That is not a complete EV. We have to know as a system how it works together, how it is incorporating the safety and reliability, and how we bring the system efficiently. After integration only, we have the real challenge. As a standalone component, it is not a bigger thing. Standalone component, it may work well, but if you start integrating all these things, that is the bigger challenge. It is creating a lot of problem once we interconnect. Example, in a classroom, students are standalone alone, they may be good, they may be behave to you very well. As a group, if you connect, they may talkative, they may disturb the class, they may make the troubles, right? If you interconnect, then only you can understand what are the problems. These fellows can talk much like that particular girl's team and all, right? So similarly, if you interconnect, sensors may give the signals in the appropriate timing. Processor may could not able to do the process, and mistiming in the relay communication may happen. It may create a problem. So after integration, we may have lot of problems. How the system level thing, how as a system, how it is going to behave, how we are going to bring the durability, efficiency, and safety into the system. That is the actual EV. Studying about motors, batteries, and the power electronics, that is there in our regular curriculum. But as a EV, you have to understand about how the system will behave, how the integration process bring all these things. That is the real EV engineering. Clear? The end-to-end spans means you are going to interconnect all the components, cell chemistry to grid, the huge power to the small cell. That is the complete ecosystem. Start with the small cell and the power grid, which is having the plenty of power. The cell has the very tiny small limited power. The entire cycle which connects all these things. So that is end-to-end span. So you have to understand all the layers of this particular thing. So after this session, you can understand well about how the evolution of EV happened over years in India as well as globally. If you understand that scenario, then we can crack bit deeper into it. How the cells evolve, how the battery technology evolve, how the motor technology evolve, how the software updates evolve over the years in the vehicle level. We are going to learn that part in the next session. Clear? So now, last 5 minutes, you have any questions? We can interact. So, ma'am, asking about costing part, right? Like that, any questions? It may be simple, no issues. Try to ask whatever the doubts you have in your brain. No questions? Yeah, then take a break. Yeah, that's fine.